Today we'll be learning about average rate of change and how to take a standard quadratic form equation and change it into vertex form. In this first example, it says the function is shown at the table at the right. Find the average rate of change over the given interval. So what is the average rate of change? Sometimes the words throw us off, but basically all they're wanting you to do is look at this table and determine the slope that occurs between these 2 points. Now, when they give you an interval, they're only giving you the x values, and so you're going to want to focus on them individually. When x is equal to 0, what point am I looking at? On a table, we have an x and a y. So when x is 0, y is -5. This will be my first point. The other end of this interval is when x is equal to 2. Come over to the table, find x equal to 2, and you'll find out that y is equal to 5. That's my second point. Now that you have your 2 points, you might want to go ahead and label them as your x1, y1, x2, y2. The formula for slope is m equals y2 minus y1 divided by x2 minus x1. So when I do this, I've got my slope is equal to y2, which is 5, minus y1, which is -5, divided by x2, which is 2, minus x1, which is 0. When I simplify this, I end up with 5 plus 5, which is 10, divided by 2. And 10 divided by 2 is 5. This second interval is written in interval notation using brackets. It just simply says that we're going to start with x equals 2 at the beginning of the interval, and we'll proceed to x equals 5 at the end of this interval. When x is equal to 2, my point is 2, 5. And when x is equal to 5, the point is 5, 35. Now I'll find the slope. I'll subtract my y2 minus my y1, so 35 minus 5 on top. And in the denominator, I'll subtract my x2 minus my x1, 5 minus 2. 35 minus 5 is 30. 5 minus 2 is 3. 30 divided by 3 is 10. In number 2, you're going to have to pull out your graphing calculator and actually graph this function. Or, your second possibility is to take your x values and plug them into your equation to find out what your y values are. Either method is a good method. I've already put the equation into my graphing calculator, so I'll pull that up now. If you're using your graphing calculator, you'll go ahead and graph, and you will want your table of values to show. In this case, they want us to focus on the interval from x equals 1 to x equals 3. So the two values I'm going to look at is when x equals 1, what does y equal? And when x equals 3, what does y equal? These 2 points are 1, 4 and 3, 26. Now that I have my 2 points, I'll go ahead and find my slope. 26 minus 4 divided by 3 minus 1. 26 minus 4 is 22, divided by 2 gives me 11. In this final example, we are provided with a graph, and we're going to use the graph that was given to us in order to find the points. The first problem says, find the interval from x equals -2 to x equals 1. So if I go to the x-axis and I find -2, I'm going to have to then go to the graph to find out what y is. So when x is -2, y is 6. When x is 1, I'll come down to the graph and I can see that y is -3. Now you actually have two options here. You can set up the equation that we've been using in the previous examples to calculate your slope, or you can actually count your spaces on the graph. Now remember, as you move from one point to the other, you do have to be sure that you're paying attention to the movement. When I move down, as I would do from here to here, when you go down, you're going to be counting in negatives. So this is a fall of -9. So I come down 9 and right 3. Right is positive. So my slope would be -9 over +3, which is -3. In this second example, I'm going to find x equals 2, come to the graph, and it's at -2, and x equals 3, which puts me at +1. Again, you can set up your equation and solve it that way, or you can count. This time I'm going up 3, which would be a +3, and right 1, which is +1. 3 over 1 is equal to 3. Now we're going to practice taking a standard form equation and changing it into vertex form. Remember that vertex form is y equals a x minus h squared plus k. We're going to use a form of completing the square. It's a slight variation because when we do this completing the square process, everything is on the same side of the equal sign, instead of us balancing the equation on both sides like we did in our previous problems. In this case, we're going to start by putting a parentheses around just our x terms. And we're going to bring that to constant on the outside of the parentheses. We're going to create a perfect square trinomial by looking at the middle term, and we're going to do two things to this linear term. We're going to half that number, and then we're going to square it. We'll add the answer on the inside of the parentheses and subtract it on the outside of the parentheses. So if I take the number 4 and I half it, I get 2. When I square that answer, I get 4. I'll add the 4 on the inside, subtract it on the outside. The reason we add on the inside and subtract on the outside is to keep things balanced. Basically, these numbers negate each other, which means we have not actually changed the problem. All right, in the second step, we're going to factor this new trinomial. It will always factor into two identical parentheses. What can multiply to 4 that adds to 4? +2 times +2. I'm also going to go ahead and clean up what's on the outside of the parentheses. -3 plus -4 is -7. Now for the final step. Instead of keeping these two separate parentheses, we're going to write this as one combined parentheses squared. So x plus 2 squared minus 7. And now we're done. In number 7, you'll notice the key difference is we have a lead coefficient. We're going to start the process exactly the same. We're going to put parentheses around both of our x terms, and we're going to bring the constant on the outside of the parentheses. We're going to look at this. Because we have a lead coefficient, we have to divide that lead number out of our parentheses. So we're going to take -3 and divide it into these two terms. That will leave me with x squared and positive 2x. Don't forget, we're going to add on the inside and subtract on the outside. Now, because we have this -3 in front, and technically this -3 is multiplying times every term inside the parentheses, it multiplies times this blank that I have put here, the one I'm going to fill in just a second. To keep things completely balanced, if I'm multiplying this blank by a -3, I have to multiply this one also. All right, to fill in my blanks, I look at my middle term, 2. I'm going to half it, which gives me 1, and square it, which gives me 1. And I'll put that in each of my blanks. This parentheses with the trinomial will factor into 2 identical parentheses. What can multiply to 1 that can add to 2? X plus 1, x plus 1. Now, when you're cleaning up these numbers at the end of your equation, make sure that you follow order of operations. Do your multiplication first, and then your addition. -3 times -1 is a positive 3, plus 2 is positive 5. Okay, so now we're ready for this last step. All we have to do is take our 2 parentheses and combine them into a single parentheses squared. Now for our last 2 examples. We'll start number 8 the same way we did the previous problems. We're going to put our x terms into the parentheses and bring the constant on the outside behind. Just like before, we're going to add something on the inside and subtract on the outside. Before I complete my square, because I have a -1 at the beginning, I'm going to need to divide -1 out of the parentheses. When you divide a -1 out of the parentheses, it is just going to change the sign of these two numbers. So now I have x squared minus 2x. I've got my plus blank on the inside and my minus blank on the outside. Now, just like before, since I have a number at the front and that number is multiplying times this blank, I need to multiply on the end also. Look at your middle term, your linear term, 2. Half it, you get 1. Square that, and you'll get 1. That's what you're going to add on the inside and subtract on the outside. Now you're going to take your trinomial, factor it into 2 identical parentheses. What will multiply to a 1, a positive 1, that will add to a -2? It is 1 times 1. Make sure, since it's adding to a -2, you use a negative on each of these. Now, when we combine these numbers at the end, remember to do your multiplication first and then addition or subtraction. -1 times -1 is positive 1, and positive 1 with -4 is -3. Now your final step. Take your 2 separate parentheses and write them as a single parentheses squared. In number 9, we're going to start the same way. Put a parentheses around your x terms. Put a plus blank inside the parentheses and put a minus blank on the outside of the parentheses. If there's a lead coefficient, you have to divide that number out of the terms in the parentheses. So I'm going to take a 4 out, which leaves me with x squared minus x. And then because I have a 4 at the front of my problem, I need to put a 4 at the end also. Now, my middle term, my linear term is 1. If I half 1, I get 1/2. When I square that number, I get 1/4. So I will add 1/4 on the inside and subtract 1/4 on the outside. Now I'm going to factor. This is going to be 2 identical parentheses. What will multiply to 1/4 that when I add it will give me a 1, a negative 1? 1/2 times 1/2. They're both going to be negative because they multiply and give me a positive, but when I add them, I get a negative 1. On the outside, when I do my combination, make sure that you do your multiplication first and then your addition or subtraction. When you multiply 4 times negative 1/4, you get negative 1. Negative 1 with negative 5 is negative 6. Now it's time to combine your parentheses into a single parentheses squared. Now technically, you're done. You're in vertex form. But a lot of times, instead of a fraction, you might see this parentheses written where they take that denominator number and write it in front of your x. So just keep in mind, you might see this written as 4 2x minus 1 squared minus 6.